Hey there, y'all. I want everybody to go ahead and give themselves a pat on the back. You've made it to the final lesson of the year. This is our last lesson. It's our last new idea, and it's the last lesson in Unit 11, and we're going to talk about similar 3D figures. So we've talked about similar triangles earlier in the year, and now we can talk about similar 3D figures, figures that have scale factors. So if we have two figures that are similar, obviously they're going to be the same type of figure. So here we have two cylinders that are similar, cylinder A and cylinder B. One's bigger, one's smaller. So they're not congruent because they're not the exact same size. But all of their dimensions will have the same scale factor. And in fact, we'll be able to find a ratio of their surface areas and a ratio of their volumes if we know their scale factor. So our scale factor is from dimensions. So for example, our radii. So the radius of cylinder A and the radius of cylinder B, if they're similar, they're going to have a scale factor. So we can write that, and we'll write it from the small cylinder to the big cylinder. We don't have to, but I'm just going to do it that way. So from the small to the big, we have B over A. So we can say the radius of B over the radius of A. If we have some other 3D figure, we can say the length of B over the length of A, or the width over the width. It's just going to be those similar dimensions written as a fraction. So if we want to find the ratio of surface areas, we'll take whatever the scale factor simplifies to, and we can square both of those numbers. So the ratio of surface areas is that scale factor squared, the top and the bottom both squared. And you might guess that the ratio of volumes is that original scale factor, the original B over A cubed. So just as a reminder, I went from small to big. So I put B on top because B represented my smaller cylinder. If we said big to small, then we would just flip all three of those fractions and have A over B, A squared over B squared, and A cubed over B cubed. So now we can use these and we can solve some problems. So here we're given the volumes of two similar prisms. And we have a bigger one, obviously, this one, 1,331 centimeters cubed. And this guy is the smaller one, 729. And we want to find just the scale factor. So what would the ratio of the corresponding dimensions be? So I like to do small to big if I'm not told which way to go. You can go big to small. It will just be flipped. So my scale factor is going to be my volume of the small over the volume of the big. Now this is my scale factor cubed. So in order to get the scale factor, I need to take the cube root of the top and the cube root of the bottom. This is the same as if you are on your calculator. A cube root, as a reminder, is the same, and I'll put x in there, it's the same as x to the 1/3 power. So if we want to find the cube root of 729, we can just do 729 to the 1/3 power. Our graphing calculators have a cube root function, so we could also use that. So it's basically what number multiplies by itself 3 times to get 729. So if we do the cube root of 729, we get 9. And if we do the cube root of 1,331, we get 11. So the scale factor, the ratio of the dimensions of these two similar prisms is 9/11. If you're having trouble finding a cube root, please make sure that you ask that question in class and I can show you how to do that. Here we want to find the volume of the larger cylinder, and we're given the surface area and the volume of the smaller one, and we're also given the surface area of the larger one. So what we're going to do is we're going to take the surface areas, and again, I like to do the small one over the big one. That's my ratio of surface areas. I can find my scale factor by just taking the square root. Since surface area is squared, we can undo these to get the scale factor by doing the square root. So no cube root necessary this time. And we're going to get some decimals. And I'll go out as far as I can. So this is our scale factor. We've approximated it because I haven't copied the entire decimal. I would have to round. In order to get our ratio of volumes, we would take the scale factor and we would cube the top and the bottom. Remember, the volumes is the cube of the scale factor. So in your calculator, you might want to do the square root of 425, get this decimal, and then just press cubed to get the exact answer. So I've done the cube of the top, I've done the cube of the bottom, and I've approximated, so I did 20.6 cubed and 31.9 cubed. I don't have a graphing calculator on me right now, but if you have a question how we could be a little more exact, we can go over that together in class, because we should be precise. So now here I have the ratio of my volumes, and I can use that to set up a proportion. I have the volume of the smaller cylinder, and I'm looking for the volume, and we'll just use V, for the larger cylinder. So my ratio of those actual volumes should be the same as this ratio over here. So now we just solve this proportion. Cross multiply. Pardon me, I had to make a calculation. I'm going to divide both sides by 8,741.8. I'm going to get the volume of my larger cylinder is approximately 4,161.7 centimeters cubed. And of course you should make sure that your answer makes sense. This volume is larger than the smaller volume, which should be the case if we've done this correctly. It's not too much bigger that it's out of the question that this is correct, so we're good to go here. And again, if we were more precise, this number might be a little bit different. And again, if you have questions about that, we can go over it in class. So go ahead and try these two. All I want you to do is find the scale factor for these two similar prisms and these two similar cylinders. And this will be the last view try you do all year. So go ahead and make sure to do it.